I'm Hazel Tomlin, one of the co-leads. I've just been looking up and down the participants list so far, and I do see many regions and countries represented in the audience, which is what we had hoped for today to encourage a diverse discussion. So this webinar will build on our last session, where we discussed the policy context of national agriculture inventories, and we will go deeper into the main issue for inventory teams globally today, which is sourcing quality activity data. So regarding the Q&A and chat functions of Zoom, please make sure your questions are posted in the Q&A section, or we could miss them in the chat. And please upvote any questions that you would like us to prioritize. We may not have time to respond to all the questions today, but the panelists will also be able to type responses to questions. So do keep an eye on your question in the Q&A function. Please also feel free to use the chat to make any comments and exchange information with one another. For the third webinar, which will be in 3 weeks' time, we will be building further on what we discussed in this session. The title is Commissioning Agriculture Inventory Research Projects, and we will email and publicly announce the link for this in just a few days with the recording from this webinar. So for now, it's my pleasure to welcome Dr. Marta Alfaro, who is our webinar chair. Marta has a long history of working in the international agriculture accounting space with a number of accomplishments to her name. To highlight just a few, she currently leads Chile's agriculture inventory team. She's on the editorial board for the IPCC emission factor database and participates as a nominated expert reviewer as part of the UNFCCC inventory review process. Marta is also the nominated representative of Chile as the chair of the GRA Council for the 2022 to 2023 term. So welcome, Marta. I will hand over to you and the floor is yours.
Thank you, Hazel, and thank you everyone for joining us today. It's my pleasure to welcome you to this second webinar organized by the Inventory and I&NDC Network from the Global Research Alliance on agricultural greenhouse gases. The aim today is to discuss around national agriculture inventory data collection, which is always a key issue for the quality and precision of our inventories, and the management. For that, we have today with us 4 great speakers. We are very thankful for their participation today. We will have a presentation from Stephen Ogle from the Colorado State University and in the Natural Resource Ecology Laboratory. Then we will have a presentation from Sekine Garasi, a senior agricultural, forestry, and other land use expert and MRB specialist. And then we will have 2 more presentations from Andreas Wilkes from the Asian and African Inventory Capability Building Program Lead, and also from the New Zealand Agricultural Greenhouse Gas Research Center. And finally, Luan Stevens from an environmental consultant and Greenhouse Gas Management Institute Fellow. So as you can see, we have a great program for this morning, afternoon, and evening, depending where you are. If you would like to know more about the speakers today, please go to the GRA website and the link that will be provided via the chat of our meeting, and you will have access there to a bio from all the speakers. So to start with, I would like to welcome Stephen with the first presentation of this afternoon in relation to general guidance on activity data collection methods. Stephen, please, the floor is yours.
Okay, thank you, Marta. I will go ahead and share my screen.
Just a short, I forgot something. After each presentation, we'll take a couple of clarification questions only, and I will have a longer session for discussion at the end of all presentations. Please, Stephen, go ahead.
Okay, thank you. Let me share my screen here, just a moment. Okay, can you see that?
Yeah, that's perfect.
Okay, great. So I'm a professor here at Colorado State University, and I have worked, I work on the US greenhouse gas inventory, but I've also worked with over 20 governments, non-Annex I parties on improving their inventories over the years. And I'm going to start out here with just some general guidance on activity data. This is always a challenge, I think, when we do our inventories, is to collect the necessary activity data. We can always use tier 1 methods if we need to, but we have to collect our activity data in order to do the inventory. And I'm just going to first have us, I want to put everything in the context of the GHG inventory. So that'll be just one slide. And then I'm going to get into the data sources, where I'll spend most of my time in this presentation, and then talk a little bit about filling data gaps towards the end. So I think we probably all know this, but when we conduct an inventory, we're estimating emissions, and we're doing that with activity data. And that activity data represents the actions of people that are influencing greenhouse gas emissions, whether that be operating a dairy, for example, as you saw that dairy cow on my previous slide, or maybe it's the amount of fossil fuel combustion in our country. And then we multiply that by the emission factor, and that's the emissions per unit of that activity, whatever it might be. One thing I want to stress here is that when we compile this data, this activity data, we should include the error or probability distribution function for that, because in the end, we not only want the estimate of our emissions, but we also want a confidence interval around that for our reporting and for policy development. So let's get into the general sources of activity data, and they generally fall into 3 different classes. One is a census, and a census is where we collect information on every activity of relevance in the country. For example, we might collect data on every dairy that is in our country. Well, that would be a census if we're collecting data from every dairy. But sometimes we don't have enough funding to do that, or time, or whatever it might be. And so we'll turn to a survey-based approach. And there we're collecting data on a sample, for example, maybe a sample of dairies in the country, to infer what is occurring across the entire population of those dairy operations. If we don't have enough money or time to do a survey, then we might choose the 3rd category here, and that's expert knowledge. And you might think about expert knowledge as not being real data, and we could argue about that, but expert knowledge is another source of information that we could use in our inventory. And I would argue that it's better to collect expert knowledge and estimate our emissions, and have an emissions estimate there, that is, rather than having no emission estimate at all for a particular source category. And then if it's an important category, a key category, then we can work our data collection into a survey or a census in the future. Now, those are the general types of data or approaches we might be using. As far as collection of that data, often this might be a questionnaire that we're distributing. For example, typically in a census, we might send out a questionnaire that households or operations would complete. But we can also use remote sensing technologies in a lot of cases. For agriculture, for example, we can gather information about land use, the amount of cropland area we have in the country, the types of crops that are being grown, et cetera. And then the 3rd one here is actual site visits. Sometimes, depending on the type of data, we may have to go visit the sites where these activities are occurring to collect data. Let's talk a little bit more about each of these. For example, that census-based method, as I mentioned, this is collecting data on all the, for example, dairy operations, or maybe on all the land, as I've shown here, these land use maps. We're collecting wall-to-wall information about land use. On the left here is a map of land use from the US, the National Land Cover Data Set. And on the right here is a map of a project I did in the past in Vietnam, looking at their land cover, land use across the country. So this is a census. It's information on all the land, wall to wall. And of course, we could do this with a questionnaire or potentially, not only remote sensing technologies, but we could visit all these sites as well. That's probably not efficient in most cases, however. Sometimes, though, we don't have funding to collect this information about all the land or all the dairy operations or whatever the activity might be that we're looking at. And those cases I already mentioned, we might turn to a survey. And I'll come back to that in a moment. I did want to mention a couple of things about a census, though, in that our goal here is to quantify the population parameter with data from all entities in the population. And by population parameter, we might be thinking about maybe the number of dairy cows in our country could be an example. That could be our population parameter. Because we're collecting data from all of those entities, we should have no uncertainty in that data. So in this case, the error should be essentially 0. But there can be problems in a census where we get non-responses, where we're not able to collect information from all entities. Maybe we sent a questionnaire out and some people didn't send it back to us, so we don't have information on some of these activities. Maybe we're using those remote sensing technologies, but we have cloud cover and we can't get data on all the area in our country. We need to address these errors, and I'm not going to get into those details today, but it's something you need to keep in mind with a census-based method. So again, as I was mentioning on the last slide, sometimes we can't do the census, and so we need to turn to other sources. Maybe there's financial, labor, or time constraints there. And when we can turn to a survey or a sample-based method in which we have this entire population, for example, the entire population of dairies in our country, and we will select a sample of those, and then we'll go collect the data through a questionnaire, through remote sensing, or some other approach. And that'll give us an inference on that population. There's a few things we need to keep in mind when we're doing a survey. And the first is our sampling frame. And by that, I mean, what dairies, if we want to use that as an example here, what dairies are we actually selecting from? So maybe some of the dairies we have in our country don't even occur in that sampling frame. They're in our population, but they're not in our sampling frame. For example, maybe we're missing the dairies from the northeastern part of the country. Well, that means when we do the survey, we will not have any inference on dairies in the northeast part of the country. So it's very important when we set up our sampling frame that we include the entire population, which would not be the case in this illustration I'm giving you, and that would be a problem. Once we have that set up, our goal then is to conduct this survey, given that sample, and derive sample statistics to make inference about the population parameters. As an example, again, it might be we're trying to figure out the number of dairy cows in our country. We would randomly select samples through a formal process. This could be simple random sampling. We might use that where we don't know much about the population. We just want to select some entities out there to sample. Some cases we might want our samples distributed across the entire country. We might use systematic to accomplish this, where we randomly locate that first sample in maybe the northeast part of the country, and then we sample ever so many of those. Maybe if it's land, we're sampling every 5 kilometers and throughout the rest of the country. We could use a stratified sampling design if there's something that's different about, we'll use the dairy cow example again, maybe our dairy operations vary across the country. So we might stratify them in some way, maybe large operations, medium-sized operations, and small operations, and make sure that we have samples from all those different sizes. And another design is a multiple stage design where we sample at different stages. Maybe we sample at a large scale using a systematic sampling design, but then within each of those samples, we might do some simple random sampling in the local area there. Once we collect this data, we'll want to evaluate it, make sure, for example, maybe like with census, we didn't get responses from everybody. That could be a problem. We need to evaluate and assess how that's going to impact the statistics that we're calculating. Once we do that part and we feel like we have a good sample, data are ready, we can analyze it given that statistical design, we can calculate those sample statistics and the variances, and then use those results in the inventory analysis. We will have uncertainty when we do a survey, and that variance calculation is very important to allow us to quantify uncertainty in our emissions estimate later. So that's something you need to make sure you're quantifying. This is an example of a survey. This is the land use cover area frame statistical survey, Lucas for short, that's conducted in Europe, looking at land use across that region. You can see it's a systematic design. If you look on the right-hand side there, they are sampling every so often. They randomly locate that first point, and then they collect a sample at equidistance across this particular region. So it has a systematic design. Here's another survey. This is the USDA National Resources Inventory conducted in the US. There's over 1 million locations that have been set out in a multi-stage sampling design here. This particular map is showing you the density of cropland from that survey, red being more cropland, blue being less. And in the US, we have higher density of cropland area in the central part of the country. If we zoom into an area here in the central part of the country, maybe this star represents one of our sampling units. And this illustration here on the right then show you what that would look like. And that square there represents the first stage of sampling. That's their primary sampling unit. And what they do is they collect an aerial photo on those, and they classify all the land uses within that aerial photo. And then they go into these crosses in the second stage and they collect more detailed information, for example, about cropping histories. So there's a two-stage sampling design here. And given that design, they can estimate the total cropland area for the country, the total area, say, in maize or soybean production in 1 year, and any other data that they're collecting at these sites. Okay, so that's a survey, but sometimes we don't have time or resources to conduct a survey for our inventory. And then we have to turn to expert knowledge. Again, better to do that inventory with expert knowledge than to have no emission estimate at all. This is certainly suitable if other types of data collections are not feasible. And this is talked about in the IPCC guidelines. There's sections there discussing how to do that. And I'm going to discuss a little bit of what comes out of those sections here in the next couple of slides. One is when we're collecting expert knowledge, we should collect from more than one expert, multiple experts, because experts will have a different experience and different knowledge about that activity across the country. And if we're relying solely on one expert, we probably are going to have a skewed view of that activity. So it's very important that we select multiple experts. We want to evaluate biases that experts may have. For example, they may focus on recent experiences, maybe what happened in the last few weeks. Maybe we're talking about manure management on the dairy. We're trying to get information about it. And they focus on dairies they visited the last few weeks. Well, that's relevant, but we want them to think about their entire experience, all the dairies that they visited. They may have limited experience in general. In that case, we may downweight that expert. They may not have as much of an impact on our final results because they just started in the job and they visited 2 dairies, and that's their limited experience. They don't know as much. There could be motivation or managerial goals that are creating biases. For example, maybe the country is wanting dairies to manage manure in a certain way, and because of that motivation, the expert is telling you more about that management system, and it makes it think that most of the dairies are operating now with managing the manure in that way, when in fact they may not be. That may be the goal, but it may not be what the dairies are currently doing. And then there's finally selection bias. Again, that kind of goes back to our selection as the inventory compiler. We want to make sure that we're selecting a broad group of experts and getting a good, robust information, if you will, about, say, manure management, wherever it might be. And finally, we want to quantify uncertainties based on those responses. By having multiple experts, we're going to have some uncertainty because there's going to be a range of variability. Another thing we can do is we're collecting individual responses from our experts. We can ask them for what they expect the range to be in those values. This is just an example from work I did several years back in Brazil with a group there in the University of Sao Paulo, in which they were, for the first time, estimating soil carbon stock changes in the lower Amazon basin there, where there's been a lot of deforestation. And they used experts in the region from a group in Brapa, their extension in that region, to understand various practices like no-till management, full-till, reduced-till management. And I'm not going to go through this table with you, but it's just to show you can gather that information and combine it and get the activity data you need for your inventory. I encourage you to look at this study for an example. Finally, just a little bit about filling gaps in activity. Often we gather this information, whether it be a census or survey or expert knowledge, and there are gaps in it, and we need to fill those for activity data. This is important for time series consistency, which is an IPCC good practice. And there are a variety of data splicing methods available to do this. You can find them in the 2006 guidelines and 2019 refinement report. 2 of the ones that I consider more robust are a surrogate data approach, where we have a relationship between surrogate data and then the activity data we need. And I'll go back to the dairy cow example. Maybe we have good data for every year on the amount of milk produced, but we have missing years where we don't know the number of dairy cows. Well, we can use dairy cows, presumably there's a relationship between the production of the milk and the number of dairy cows, and we can, because we have the milk produced every year, we can then estimate the number of dairy cows in those missing years. We develop a relationship in the years in which we have the number of dairy cows to create this, this estimate. We can also use trend interpolation or extrapolation, quite common. A lot of inventory compilers will use this, where they basically fill in the gap as whatever that trend is over time, connecting those dots, if you will, on the left side here with a linear interpolation, or maybe extrapolating out in a time period where we don't have inventory data using these methods. We can often do this with simple linear regression models. Just a few conclusions here. There's three basic types of data collection, as I mentioned: census, survey, and expert knowledge. And we should use the one appropriate for our circumstances. Ultimately, it'd be great to use a census in all cases, but that's not always feasible. So sometimes we have to turn to survey or even expert knowledge. We want to quantify uncertainty so error can be propagated through the inventory analysis. A well-done census, there will not be uncertainty, but there will be in a survey and expert knowledge. And finally, we want to fill gaps in our activity using appropriate data splicing techniques, such as the surrogate data method or extrapolation interpolation methods. And with that, I'd just like to thank you for your attention.
Thank you, Stephen, for a very concise and clear presentation. We have time maybe for one clarification question, if there is any from the floor. Maybe, Stephen, if you could provide your view on the use of these different techniques or to fill the gaps, and the combination with different tiers when implementing the inventory.
Yeah, that's a good question. I will be honest, in our inventory, we tend to use more of the interpolation, extrapolation methods. I would like to use more surrogate data methods because I think they can be more accurate in the end. There's more information in that surrogate data than a simple time series relationship that you might have. But they are more complicated it's more complicated to get that data and determine those relationships. So we tend to use more interpolation, extrapolation approaches to fill in those data gaps.
Thank you, Stephen. We have more questions. I will ask our colleagues to keep those questions in mind for the final round of presentations or discussion at the moment. So thank you, Stephen. For our next speaker, it's Sekai Ngarasi. Thank you, Sekai, for joining us this afternoon.
Thank you. Let me just share my presentation.
Yes, please.
Okay, it's in the right mode, right? You can see now?
Yeah, that's perfect. Thank you, Sekai.
Okay, thank you. Thank you for allowing me to be part of this excellent group. My presentation today will be looking more at the international perspective with regards to data collection, but also management of data. The outline of my presentation will be looking at sort of understanding the international context in terms of climate change policy with regards to agriculture, GHG compilation and reporting, but also looking at the IPCC and UNFCCC decisions, including the most recent Paris Agreement common tabular tables, which will be the future in terms of how we report the information that we have estimated in our greenhouse gas inventories. And then the other thing coming back at a national level, but also maybe starting at a global level, a conceptual framework for collection of agricultural statistics and data, and the need for legal or institutional framework for collecting agriculture data. And then I'll look a little bit at agriculture data collection. And from that, there's an example of a framework for collecting activity data from livestock, but also there are other examples included there. And then we'll look at one example of online data management tool from South Africa. So in the international context, as you may be aware that countries have to report their greenhouse gas emissions and removals from all sectors, of course, including agriculture, via their national greenhouse gas inventories, which are then submitted to the United Nations Convention on Climate Change. Greenhouse gas inventories are estimated and reported in accordance, again, to international climate policy agreements and technical guidelines developed by the Intergovernmental Panel on Climate Change. I think Steve has already alluded to that in his presentation. One way of actually tracking progress towards NDC's nationally determined contributions is through the use of national greenhouse gas inventories. Again, as you know, the agriculture sector is one of those sectors that are included in a national greenhouse gas inventories. So inventories play an important role in the transparency framework through which progress towards national and global climate action goals are tracked. Maybe just a little bit here of an international context. At the moment, under the current MRV frameworks, the unique feature lies in the legal nature of greenhouse gas inventories for developed countries. The so-called Annex I parties, they have to submit their national greenhouse gas inventories on an annual basis. And increasingly, the developing countries, as you will see on my next slide, there'll be a requirement to produce biannual national greenhouse gas inventories, and agriculture is of course included. Maybe the latest one here is for those of you who are participating in negotiations. At COP26 in Glasgow, parties adopted the guidance on operationalizing the modalities, procedures, and guidelines for an enhanced transparency framework under Article 13 in the Paris Agreement. As you can see there, there's many other things that were adopted there, but I've highlighted in orange there, which is the common tabular reporting tables for the information on national greenhouse gas inventories. I have an example here from agriculture, which I may show maybe at the end of my presentation, just to avoid a disconnection. I won't go through the other things that are listed there, but as inventory compilers, you need to understand how the inventory, whether it's agriculture or it's energy sector or any other sector, is used in terms of translating that inventory and looking at mitigation scenarios. As you can see here, many other things were adopted. So your electronic tabular formats, which link what you've done in the inventory with your mitigation scenarios and so on. So I won't go through the other elements that are listed here, but the most important one is the one that is highlighted in orange. Agriculture represents a very unique sector, but also is one of the most challenging ones to compile, in particular in developing countries, due to the challenges of collecting activity data. I think Steve highlighted quite well in his presentations, as you saw, that collecting activity data for agriculture is quite intense. So increasingly, there is now a requirement for countries to regularly update their national statistics on agriculture. Therefore, because of that, there's a need to formalize data collection and also data management. So what do countries need to do in order to formalize the systems for data collection for agriculture? As you can see here, I have a conceptual framework that translates agricultural statistics and data into information that can then be used for compiling the inventory. So essentially, a conceptual framework translates your policy issues into statistical language by identifying the need for a survey framework, which then links your farm as an economic unit to the household as a social unit, but also to the land, where a lot of these human or management impacts take place. I think Steve also highlighted that in his presentation in terms of how we collect our activity data. I like this second point there. This is something that the FAO has been doing for some years now, and increasingly, I think the FAO is one of the institutions that are actually providing data for inventories, albeit to say they are tier 1 inventories, but at least it's a start. So the framework suggests that the fundamentals of a global strategy should be based on these 3 pillars. First, you need to identify a minimum set of core agriculture data in terms of your activity data, and then look at how you can then integrate agriculture data into national statistics. Here I can give an example of the work we did in DEFRA with colleagues in the UK. I'm not sure if there's anyone from the UK. I don't think I saw anyone on the list today, but we used to do a lot of research in agriculture in terms of collecting activity data. So you need to think about, if you do a survey, how do you then translate that research or the outputs from that research work into data that can then be formalized and used in greenhouse gas inventories. So this is very important to link how the collection of data in this, whether it's surveys or censuses, is then taken and used in the GHG inventory. And then the third pillar is the third pillar on sustainability of agricultural statistics system through governance and statistical capacity building. As you know, sometimes when the data is collected, is not in the format that can be easily used in the GHG inventory. There's some processing that takes place before it can be used as activity data in a greenhouse gas inventory. So it's very important that you have a framework that allows you to, when you collect that data, to be able to use it in the greenhouse gas inventory for agriculture. And then the Paris Agreement ETF requires that all countries, not just developed countries, including developing countries, have a formalized data collection strategy. This means that there is a need to establish permanent institutional framework, which in some cases is actually mandated by climate legislation. Again, I can give an example. In the UK, they have a Climate Change Act, and increasingly a lot of countries have some form of climate legislation or something that requires data providers to set up data sharing agreements with countries so that the data, be it for agriculture or any other sector, is collected on time and in a format that can then be used in your greenhouse gas inventory. This slide is based from some of the work from the IPCC 2006 guidelines. As you can see, the IPCC provides a systematic approach, if you like, of compiling data. So first of all, data collection is an integral part of developing and updating your agriculture inventory. So formalizing data collection activities should be established and adapted to your national circumstances. Again, they need to be periodically reviewed in case you've got a new census or you've got new ways of collecting information, or in fact, maybe you have developed a tier 2 emission factor or activity data for that matter. Data collection procedures are necessary for finding and processing existing data, as well as generating new data, whether through surveys or through measurement campaigns. So when you collect activity data, it's also important that you have values. For every value that you collect, you also have the uncertainties that are attached to them. I think also Steve highlighted on this point in his presentation. Again here, what do countries need to do to develop a data collection strategy? In accordance with the IPCC guidelines, so if you like, you can follow those 3 steps there. First, you must develop a data collection strategy that meets your data quality objectives regarding the timeliness, the consistency, completeness, comparability. I mean, it must meet the IPCC quality principles, what we call the TAC principles. Data acquisition activities should also include, in some cases, generating new source data, dealing with restricted data, confidentiality, but also expert judgments, as we have had from the previous speaker. There is also a third step where you look at turning raw data into a form that is useful for the inventory. Like I said in my previous slide, that sometimes we have activity data or data that is not in a format that is needed for the inventory. So it's important that when you come across that type of data, you are aware of the IPCC approaches that can be used to translate that data into a form that can be used for the inventory. This part of my presentation, I'll present a framework that can be used for collecting activity data. I must say this was adapted from the FAO and the GRA Livestock guidance that was developed in 2020. This is a very, very useful resource for all compilers, regardless whether it's developed or developing countries. It gives you some guidance, if you like, on collecting the data. Of course, here we have the possibility of not just doing a tier 1 inventory, but also doing a tier 2 inventory. So it's very important that you follow the steps that are outlined here. So the first step really is to define your activity data needs. Yeah, and then in the second step, you collect your data, but you still need to assess the availability of that data. So this framework really almost acts like some kind of a decision tree, if you like, that helps you to decide which pathway to take depending on the quality of the data that you have on the ground. Of course, there's always room for improvement. So once you have that data, you want to assess the quality. If the quality is good, you can go ahead and compile an inventory. But if it's not good, then you have to decide whether in some cases you want to even have studies or have surveys that will allow you to collect that data and so on. So in some ways, when you do this, you also are following the inventory cycle that the IPCC outlines. So this is just a schematic framework. This maybe the more sort of detail on what you do for each of those steps that you have seen that are outlined there. The first step when we talk about defining activity data needs, it basically involves, for example, deciding what livestock categories exist in your country, or which livestock categories do you want to include by population type and so on. Or in some cases, cropland areas and the amounts of fertilizers that are applied, area of organic soils or histosols. And then the second step is to collect that data. But again, to collect that data, you need to know which stakeholders may be able to provide what type of data, but also establishing institutional arrangements for obtaining that data. In some cases now, I think on a regular basis. For some countries annually, for some countries it will be every 2 years. So it's very important to have a systematic framework for collecting the data through either use of data templates that are designed to collect the type of data that is required for the inventory. Again, some countries are using memorandum of understandings or through sharing, through data sharing agreements. The third step is essentially, again, assessing the data using a systematic way of assessing the data that is available. In terms of livestock, again, you can characterize your livestock subpopulation in a consistent way and so on. And also, you can also look at other parameters as well in terms of crop production data. This may also result in you identifying the gaps. And if there's no data, again, you use those gap filling techniques, which have been highlighted in Steve's presentation. Assessing the data quality involves assessing what type of data do you have? Does it also result in gaps? If there are gaps, can these gaps be filled in? If not, what do you need to put in your improvement plan? Step 5, again, I won't repeat that. I think we have heard from the previous speaker, use the use of IPCC gap filling techniques, but also step 6, compilation using adequate quality data. This is very important in terms of the quality of the GHG inventory that will come out at the end here. Again, this part also involves documenting the processes that were involved in collecting the activity data and so on. And then inventory quality assessment, again, here again, you can also do your uncertainty analysis to identify the priorities for future improvements in your greenhouse gas inventory for agriculture. And then, as you know, development of an inventory is a continuous process. You are always improving your inventory all the time. So it's very important to draft and implement an inventory improvement plan for all the sectors. Of course, here we are dealing with agriculture sector.
I'm sorry, Sikai, we are running out of time. Could you please wrap up your presentation?
Okay, just to wrap up, this is my last slide, my second last slide. This is an example of a national greenhouse gas inventory management systems from South Africa. Probably we won't have time to discuss much on this, but I know Luwen is in this meeting. So if you want to understand a bit more about how these systems are set up, you can contact Luwen. I'm sure she'll be happy to ask or respond to any questions that you have. But maybe the key point is to highlight that a lot of these national greenhouse gas inventories systems are designed to ensure transparency, but also they are web-based, which means that it can be in the form of a database, and that database actually acts as system of managing your data, sharing, but also storage. So that's very, very important. Increasingly, a lot of countries are actually moving to sort of web-based platform tools where they compile the inventory and they have all the data sets that are used to compile the inventory on that web platform. Just to summarize my presentation. So the first thing is it's important to understand the international climate change policy context with regards to agriculture compilation and the relevant UNFCCC decisions, and of course the IPCC methods. Please familiarize yourself with the Paris Agreement, common tabular format, because this is how we'll be reporting the agriculture inventories in the coming years. Use of conceptual frameworks in terms of having a systematic way of collecting your data for agriculture. Need for legal and institutional framework to mandate data agriculture collection on a regular basis through use of course, data sharing agreements and so on. The need to design a framework for activity data collection and data collection templates for agriculture. And of course, how you decide to manage that data depends on the national circumstances and of course, the funds available to design these systems. They come at a cost. Thank you.
Thank you very much, Sekai, for a very detailed presentation. We won't have time for clarification questions, so we will go back to you during the discussion round at the end of the session. Thank you for that.
Thank you.
Next, we would like to welcome Andreas Wilks to join us for the following presentation on livestock activity data. Please,
thank you,
Andreas,
Marta.
the floor is yours.
Yeah, okay, just bringing up my slides here. Please tell me when you can see that in full screen. Is that okay?
That's perfect.
Great, thank you. Yeah, so both Stephen with his dairy examples and Sekai also mentioned a lot about livestock activity data. So I'm going to go into a little bit more detail on that. For those of you who don't work on livestock, don't worry, the next presentation is not about livestock. So what are the issues in livestock activity data collection? I'm going to be talking a brief background on what is the particular relevance of activity data on livestock, and briefly go through some common challenges and options that certainly I'm speaking from my experience, which is much more working in developing countries, less so. Some of the issues I'll be mentioning are less common in the Annex I country inventories. And finally, just want to point you to some resources and highlight some future needs to help address some of the common challenges. So the relevance of livestock activity data. So this chart here uses FAO stat data just to show the livestock emissions in Annex I and non-Annex I countries, so the developing countries. And you can see from in the blue, so the developed countries' total livestock emissions have been gradually decreasing, whereas the opposite is happening in developing countries. So livestock emissions are accounting for an increasing proportion of agriculture emissions in many developing countries. And they're a major emission source. How to accurately depict them in the inventory is a common challenge. Many of you will have seen these two diagrams before, the difference between Tier 1 for livestock, the IPCC Tier 1 method, and the IPCC Tier 2 method. So in brief, the Tier 1 method is number of animals multiplied by the emission factor per animal. And it's not very useful for policy purpose, because those of you with a mathematical mind will realize the only way to reduce emissions is to reduce number of animals, which in very few situations is that an immediately feasible policy. With Tier 2, the equation is slightly more complicated. We break down livestock populations into different subgroups, like young animals, growing animals, mature animals, animals in cattle in different production systems and so on, and then estimate the energy intake per animal and the units of emission, the emissions per unit of intake. So with this, actually, there's a lot more that you can do to change emissions. You can change intake levels, or you can change the emissions per unit of intake, as well as changing the structure of the population. So the Tier 2 method is much more useful for tracking the effects of policies and measures in the livestock sector, such as increasing livestock productivity, changing the structure of the herd, or shifting the mixture of species. And so there's quite a lot of interest in how to implement Tier 2, but also a strong perception that it's too difficult. We don't have the data in our country, we can't do it. That's quite a common perception. And so in the last few years, together with other colleagues, we've been working in many developing countries to show, well, actually you can do it. I think even, Stephen gave you the ultimate answer. If you don't have the data, well, use expert judgment rather than nothing. So, it is possible to do Tier 2 in line with the IPCC guidance, no matter what kind of data you have. To date, although about 100 developing countries have included livestock emissions in their NDCs, but so far as I can estimate, less than 30 of them use this Tier 2 method. So it's important to dispel some of the perceptions about activity data being too big a challenge. What are some of the common challenges we do run into? So the first, around data availability. In some countries, data on total populations of different types of animals, so the total cattle population, total sheep or pig or other population is not always available. One of the challenges is that censuses, so the full census in many countries is very infrequent. A lot of countries haven't even managed in the last 10 years to implement a census, or have just, they do so at 10-year intervals. So how do you estimate the population in between? We also often find that annual statistical surveys, they only cover some production systems, like they will sample rural households, but not sample commercial farms. So there is often only data on some of the population available. And when you break down, for example, cattle, you divide them into groups by age and sex or different feeding systems. Often there is incomplete data on different subcategories, or even totally missing data on subcategories. And I think we're all aware that incomplete time series, so if we move from Tier 1 to Tier 2, we have to do that for the whole time series since 1990 or 1994, whatever the base year is, and often there's missing data. So quite common challenges around population data. There's also some methodological challenges. In some countries, I'm thinking, for example, West Africa, the countries of the Sahel, a lot of mobile livestock, even mobile, moving across national boundaries, and data collection in these systems is a challenge. It's often difficult collecting data on populations in commercial subsectors. In many countries, the government doesn't have full information even on which how many farms there are which have animals. And as Stephen mentioned, sometimes there's no sample frame. So there's no list of farms from which you can then go and do sample for a survey. I think some colleagues in Ethiopia recently have been working with the Statistics Authority specifically on how to develop a sample frame for commercial livestock sectors. And in a lot of countries, we run into an issue that IPCC has a quite particular definition of dairy cattle. It's cows that produce milk in commercial quantities. but often that doesn't really well capture the ways in which dairy production or dairy animal performance is different from non-dairy animal performance in developing countries. So, a lot of some methodological issues alongside the pure data issues. Animal performance data is also perceived as a big challenge, even if a country does have the population data. So if you look at the IPCC equations, it looks all terrible. There's a huge number of parameters, but at the end of the day, it's about 7 or 8 parameters that are needed for cattle, a couple of extra ones if you're doing small ruminants. And among these, in general, the most important, or the factors that really drive uncertainty are live weight, because that determines net energy for maintenance, which is the majority of net energy needs, feed digestibility, and the methane conversion factor, which also depends in part on feed digestibility. So if you didn't have a lot of money to go off and do research and collect all the data required, if you target limited resources to certainly the live weight and feed digestibility, that would be your best bet. Common data challenges we do come across is the availability of data, not necessarily the data on feed chemical composition, the data on diet composition. What are the animals eating? What percentage of this or that? Often that data is overlooked, and it's not often reported in scientific papers, partly because it's not a very hot science topic to get published in a high quality journal. So, you know, there's often a surprising lack of data on, well, what are animals eating in a country? Where there is data, often it's not fully representative of the country or fully representative of a production system. And because of the large amount of data needed, there's a challenge around what are the most cost-effective data collection methods. There's a lot of very good high quality scientific methods, but it's hard to apply them, or very costly to apply them at a national scale. And then you have the type of questionnaire methods that are used in national statistics, but they're not always or it's difficult to get accurate responses using some of those methods. So some particular challenges around measuring animal performance. Manure management, a lot of attention paid to measuring methane conversion factors, nitrous oxide emission factors, but actually in very few countries is there any data on the percentage of manure managed in different manure management systems. Or, you know, often on a farm, first it's managed in this way, and then, you know, then it's scooped up and heaped here, and then it's applied there. So how the manure flows through different management systems and how long it spends in each system. Manure management is rarely incorporated in national statistics in developing countries. So very common to find an absolute lack of data on this. And again, the scientific community tend to focus on, you know, the nutrient qualities or other particularly scientifically interesting issues around manure management, but not necessarily to have looked at, well, how is manure managed across a large sample of farms. So, I mean, there are some resources available that hopefully can help. The ones Sekai just mentioned, the livestock activity data guidance produced by FAO together with the Greenhouse Gas Research Alliance. There's also an associated website, www.agmrv.org, which gives a lot of sort of background material, but also lots of case studies of how did different countries deal with different aspects of activity data collection and analysis and so on. And so this guidebook, it basically says how to make the best of available data, and then how to work out where to target your resources for collection of additional data. And it mentions issues like surrogate data that Stephen touched on, the proxies and different gap filling methods, and it gives some worked examples and methodological guidance. So hopefully that's a very good resource. I think the next step is to overcome, to move beyond where we are now. First big question is to really get a better understanding of what are cost-effective data collection methods. As I mentioned, high resolution, highly accurate data is costly to collect. But so if we use second best options like questionnaire surveys, then how much do we lose in terms of increased uncertainty or accuracy? There's been very little research on these kind of topics, and that would be really useful for knowing how to target the limited resources to data collection. A second obvious gap is guidance on how to collect data on the proportion of manure managed in different manure management systems. It sounds very easy. You've got the 10 or 12 IPCC defined manure management systems. You go out and you ask a farmer, which ones do you use? There are a lot of quite technical issues in the way the questions are asked, the way manure management systems are defined so that they match with IPCC, but they match with local terminologies. And the supplementary questions that you can ask about residence time and so on and so forth. So far as I'm aware, there's no accessible guidance on this topic. That would be a useful thing to see. And the other thing is making available data accessible. There is a lot of data out there, a lot of it in published form, in scholarly theses, in various databases. How can we make sure it's available for entry compilers? And I'm thinking in particular data on diet composition and associated feed chemical composition, the feed quality data, because that's an important driver of livestock emissions. And final point, at the country level, we really need collaboration between stakeholders to improve livestock data. Bearing in mind, better data on livestock is primarily not useful just for the greenhouse gas inventory. It's useful for all sorts of things within the sector, livestock sector planning, planning for vaccination campaigns, investment planning, and so on and so forth. So how can we work together to make sure the data gets collected that greenhouse gas inventory compilers as well as others need? So just 3 points in summary. There's a lot of demand to improve livestock greenhouse gas inventories, particularly in developing countries where it accounts for a large proportion of the emissions. There's a continued need for user-oriented innovation and guidance on how to address these activity data needs. The livestock activity data guidance was a good start. There's a lot more that can be done. And finally, just to remember that better livestock data is not only useful for greenhouse gas inventories. I'm sure there are many other reasons we can convince stakeholders to work together on addressing these challenges. So I'll leave it there for now, but look forward to discussion later. Thank you very much.
Thank you, Andreas, for your very thoughtful presentation in relation to the challenges we face when collecting data for estimation of emissions from livestock. We will take, there are a couple of clarification questions for you in the question and answer section in the chat, and we will take more questions for you during the discussion. To continue with our last but not least presentation, we would like to welcome Joanne Stevens, and she will be presenting on the relevance of and the challenges we face when collecting data for estimate emission from agricultural soils. So Andrea, if you could stop sharing your screen. Ah, you did, thank you. Luan, are you there?
Yes, I'm here.
Thank you.
Right. Okay. Great. Yes. Hi to everybody, and thanks very much for giving me opportunity to speak at this webinar. It's been very interesting so far, and I can see lots of similarities and needs and across the presentation. So it's good to see. So I'm going to be talking a little bit about the agricultural soils and the challenges with those. I speak mostly from a sort of from a developing country, from experiences working with various different developing countries. You'll see I've worked recently on the Caribbean as well, and some in Eswatini and South Africa. So you'll see some examples from there, but I'm talking generally about my experiences mostly with African countries. And so we'll have a look at some of the challenges and requirements for data. So just generally to look at the importance of agriculture soil emissions, and then to look at some of the current data sources and data collection processes, challenges, and then possible ways forward and needs going forward. Just recently, in an FAO report, we can have a look at the contribution of crops and livestock activities to global non-CO2 emissions. And we can obviously see that livestock has the largest portion, but there is still a fairly significant portion from agricultural soils with synthetic fertilizers, crop residues, and drained organic soils. So not as large a contribution from livestock, but still nevertheless important. But what is interesting is really looking at the change in these emissions over this time period. And we can see this is where really we start to see the importance of understanding and collecting good quality activity data, particularly in terms of synthetic fertilizers and crop residues, because these are showing greatest emission changes over time. So it's important that we start to have a look at these aspects and try to collect some activity data. So I'm just going to look at the different aspects of these. So synthetic fertilizers, which is the amount of your activity data, is the amount of fertilizer applied to the soils. And when we look, generally at developing countries, we find that if countries do not have data, they may rely on the FAO stat data that is available. Otherwise, it usually comes from survey data or for customs data from import and export data, seem to be the most common data sources for this activity data set. And this is usually really done through questionnaires, through agricultural extension officers, or collecting data from customs. There's not usually any formal data arrangements that are set up. And so the challenges with collecting data is that we're dealing also a lot with a lot of subsistence farmers, and they don't keep records. And so if you have questionnaires and how much fertilizer did you use over the whole year, they don't really know because they haven't been collecting the data. So there's lots of challenges with working with small scale and subsistence farms. And so, we may need to look at alternate sort of data sources. And one of the sources may sort of be that we need to look at like umbrella organizations. For example, in South Africa, there's a Fertilizer Association of South Africa. This is really an organization where companies that produce fertilizers all come together and share their information. And so the association already collects a lot of information. And so these sort of larger umbrella organizations collect information for other purposes, but it can still be used for inventory purposes. And they also, are in between. When you go to industry, sometimes they don't want to share the information, whereas it's useful to share it with they're happy to do it with the umbrella organizations, and the data gets aggregated, and therefore it's easier to use and share from that point of view. So sometimes it's quite good to look at these larger organizations that already collect some of this information. There's also, in terms of there's also an aspect of if you have a lot of information on the nitrogen fertilizer use from various crop types, you have an application rate, and then you can move into looking at modeling and forecasting fertilizer use as well. But for this, you have to have had quite a lot of data over a lot of time. But it is something to think about as we move forward. Sorry. If we're looking then at organic fertilizers, there's also an input, and this really in the inventory involves any kind of organic inputs, usually from animal manure or compost or sewage sludge. And generally we find that only the animal manure inputs are included, just because it's very difficult to know exactly how much compost or sewage sludge was applied in the field. And most of the animal manure inputs into the soil are obtained from information coming from the livestock sector. So I'm not going to go into that because we've already had Andreas talk about the livestock and then looking at the manure and the manure management. And as he highlighted, one of the challenges here and the greatest uncertainty is the collection of manure management data. That's probably where the biggest uncertainty is, and mostly people use expert opinion to obtain this type of information. And I think this is true also on any kind of nitrogen inputs from urine and dung. It also relies on information coming from the livestock sector. So improved livestock data can lead to improved emission estimates from agricultural soils. It affects the inputs for direct and indirect emissions. So, having a look at improving activity data on the livestock and manure management side also leads to improved accuracy within the soil section as well. So in terms of crop residues, which is the amount of crop residues applied or incorporated into the soils, this is also a very difficult data for developing countries to get a handle on how much is actually incorporated. So it's often not included. If it is included, it's usually estimated using the IPC methodologies, using crop area and harvest area and yield data. In many cases, this is obtained from the FAO data set if country data isn't available. And country-specific data is often available from agricultural statistics. They usually have data on areas and at least yield data. And so a lot of this information can be used to estimate the amount of crop residues produced. But of course, once you know how much crop residue may be produced, the real challenge is understanding what the crop residue management is. How much of it is burnt, how much of it is collected, how much is incorporated into the soil. And this is similar to your sort of manure management data. So the crop residue management data is also quite a big uncertainty because it usually comes from expert opinion as well. So we can also have a look at, doing surveys or research studies. These have been mentioned before. I think that in some cases, obviously, we'd like to have sustainable data sets, but sometimes funding is available on a project basis. And so if we can do surveys on a project basis to collect information on crop residues over a large area or for certain crop types, then countries can slowly gather some of this information to support the understanding on how residue is managed for the various different crop types. So we can use both expert opinion and also try to move towards gathering information through these surveys or research studies. The other component that is included is information from soils, the amounts of nitrogen mineralized in association with loss of soil organic matter, which is related to land use change or management changes, and also due to drained organic soils. In a lot of developing countries, this type of information is not really included due to a lack of data. A lot of it relies on information coming from the LULUCF sector or components of the inventory. And so countries that don't have information on land mapping or land use changes or soil maps may lack this information. But I think it's also sometimes we just need to raise awareness that there is the link and make sure there is the link between the two sectors as well, so that the data can start to be incorporated. I think that we have recently seen lots of improvement in land use change data, particularly through the use of the FAO Collect Earth data. We see lots of, we've seen in Eswatini recently, they have used the Collect Earth data and managed to map out land use over the last 20 years on an annual basis. So, you know, there's lots of possibilities using technology such as Collect Earth. Again, one of the aspects here that we need to look at is land management. As been mentioned before in terms of, for example, tillage practices, what is actually happening. Again, this is an area of great uncertainty and where it often relies on expert opinion. So it's always these management type of data, as Andreas said in his presentation earlier. These are not often data sets that are included in national statistics or any kind of data. And so that is why it's heavily reliant on expert opinion. And this is an area where maybe surveys or combining with research organizations to try to collect more of this data, even if it's a once-off or repeated every 5 years, it's better than no data. So this is the type of information that I think we are lacking here, is more the management type of data as we move forward. So as I say, we've mentioned a lot of challenges. You know, subsistence farmers, they don't keep records, as I mentioned, with the synthetic fertilizers. It's really difficult to keep a record over a whole year. Their crops change, so it's difficult to obtain information from farmers. Extension officers, I think extension officers or data providers are not always aware of the data requirements that are needed for the inventory. And I think this is a big issue that we need to build more awareness of what type of information is required. Sometimes even when you talk about what the data requirements are, you'd be surprised at what kind of information comes out and what can actually be found. We need to formalize no formalized data collection processes, which it makes it challenging and time consuming to collect all the data for all the inventory compilers to go around and collect all the data. So formalizing data collection processes creates a more stable system. As this was mentioned before, infrequent agriculture census and gaps in data. So we're not going to look at that. Lack of land use change or management data, and of course capacity and resources is always difficult in developing countries. Just looking at some ways forward, I think, as I've mentioned, building awareness on data providers of what is required is an important step, and to build relationships with data providers, not just to see them as someone to give information. They're actually quite interested often in wanting to know how the data is used and what benefits them. So if you can highlight benefits or consider incentives, or if you can explain and show them or the use of the data, it brings in their interest as well and provides a good basis on relationship to build and to obtain further data. I think looking at existing systems and building more information from inventory relevant data into current surveys or census is something that should be considered. We should look at the census data surveys. Maybe just 1 or 2 questions can be added or asked in a different way to gather a bit more information. I think this is something that we need to consider. I mean, there's things like farmer registrations in some of the countries, particularly they have to register if they want disaster relief, for example. Is there some way that we could use this, maybe, as I say, tack on another question, or livestock registration? We need to look at the existing systems and how we can use them going forward as well. Set up formalized data collection systems. We've already talked a little bit about that. Can also consider regulations. In South Africa, they have a greenhouse gas emission regulation, which was really brought in to have industries and companies report on their emissions. It's not extended to the agriculture sector at this point, but it could be looked at in terms of extending it to certain circumstances. Obviously, the impacts have to be considered carefully before doing this, but these are all things that need to be considered. As I've mentioned, maybe partnering with research organizations to undertake project-based studies. If there is often project-based study funding available, then this is, I know it's more static and not so sustainable, but at least it provides you with some backup information to support the information from, for example, expert opinions. It's still useful information. It's better than no information. And as I've mentioned before, using umbrella organizations, they really are useful between the people on the ground and between companies or farmers, and they already collect a lot of aggregated data, which can be very useful. And then I think also we need to think a bit about using technology and software and apps. We've spoken a lot about various tools that are available. We need to think about apps. A lot of agriculture apps are used, providing, especially particularly linking farmers to markets, for example, or, we just need to think creatively, I think, because a lot of farmers may have cell phones and apps. And so this is something that maybe we need to consider going into the future. And also, again, sort of capacity building is always a requirement, I think, in these areas. So the takeaway messages really are to build awareness. I think this is really important, to make people aware of what data is required. And to look at, of course, the main aim is activity data. I know with livestock, we're looking more at improving to tier 2 emission factor data, whereas really with the soils and the activity data we've mentioned here, the activity data is driving it, so that's particularly important. And improve ways to collect management data. And mentioned crop management and manure management and land management. These are the data sets where I think that there is the greatest uncertainty in a lot of inventories at this point. And just get creative and think about ways to use technology to collect various data going into the future. So yeah, thanks very much.
Thank you, Luan, for your comprehensive presentation, and thank you to all our speakers for joining us today. We have 10 minutes for an open conversation and discussion around the different topics you have all provided to us. We have several questions in the chat. I think the most voted one at the moment is related to this perception of that, particularly in a non-Annex I country, there is no information, or the difficulties to collect, to have the appropriate activity data for the estimation of our inventories. But it's a very good point from a colleague in the chat in relation to that this may not be lack of availability, but just difficulties for sharing data. And from that perspective, what is your opinion around this? And also what's the relevance, if that is the case, of having adequate memorandum of understanding between the different institutions participating in the inventories, and also the role of the different stakeholders we can find in our countries. So if I open the floor for our speakers to provide their views. I don't know if there is some of you that would like to start, maybe.
Okay, maybe I'll jump in for that one, because I don't know if all the participants here are aware that there's an initiative called Capacity Building Initiative under the Paris Agreement. And at the moment, there's a lot of work that is going on under the Global Support Program with UNEP. Jeff is providing money to developing countries to set up their national systems. And as part of that, they are also basically restructuring their MRV system so that they can report under an enhanced transparency framework. So there's a lot of finance flows that are going in to support countries to restructure their institutions so that they can actually better manage all climate reporting data. And this includes data from the agriculture sector. At the moment, I've done, I think, 2 countries. I've worked with Zimbabwe, developed their framework, if you like, an implementation framework for the ETF, not just for greenhouse gas inventories, but also for the mitigation assessments, for the adaptation component. So there is money that is going, and some countries are beginning to consider the use of legal instruments to mandate data sharing. Sometimes, as one of the colleagues just said here, that it's not because the data is not there, but it's not shared. So most data providers maybe are not in a position to share that data if there is no institutional framework that supports the data sharing component. So there's a lot of work that is currently going on, and countries can apply under the CBIT. Basically, I think Jeff is providing money through UNEP. So a lot of countries can put in their proposals if they want to set up maybe an online data management systems. For example, here in Zimbabwe, I have worked with some of my colleagues at the climate change department. They are actually using the IPC software to estimate their emissions, but then they want to move all that data into a system that can manage all climate reporting data. That includes the greenhouse gas emissions for each sector. And they are calling that National Greenhouse Gas Management Platform. I think there may be other people in here who have even better experience from Annex I parties who are maybe quite a long way ahead in terms of setting up some of these systems.
Thank you, Sekai, for sharing that with all of us. I don't know if any of the other speakers would like to have an opinion on this or would like to share experience in relation to this. No, then I will move to a specific question for Andreas in relation to the requirements or the need when we categorize the cattle. And we need to, when moving into tier 2 or tier 3, we move into more a detailed categorization of the cattle. So when categorization is enough, or when do we have enough groups of animal groups for the estimation of emissions?
Good question. In compiling a tier 2 livestock inventory, defining the animal categories is the most important question. Almost as important as all the data issues around what data is available. If you can get that right, you know, how many categories should we have, which categories should we have, even if you have missing data, then you've got a good structure for your inventory to fill the gaps in the future. I don't know what the right answer is. You know, what categories are represented in national statistics. You normally follow that, otherwise you can't get a consistent time series. The second factor would be, you know, how big do you expect the emission factors to differ between different subcategories? So you find some countries, they combine male and female calves into one category, calves, because the difference is not so huge. But you might find in some countries, there is a reason why you'd want to keep them separate. The third reason really then is you want to think about how to keep this practical for the inventory compiler if they have to compile this every year. So, you know, how much is too much? Look at it from a practical angle, not necessarily the numeric side of things. So there's no right answer, but I think between those 3 factors, you would find a happy balance.
Thank you. Thank you for that answer. Maybe another question for Luan and Stephen, maybe in relation to the high variability that we usually find in activity data from one year to the next one, for instance, in relation to the amount of residues incorporated in the soil, or given the current prices in fertilizer, the end rates applied every year, or particularly this year. So how do you deal with that variation when you don't have proper census or annual statistics, for instance, if you have a view on that? I don't know who would like to go first. Stephen?
Well,
Thank you.
I could maybe speak to it. I'm sure Luann can add some as well. But yeah, fertilizer rates, we actually used we looked at two data sources. We looked to a top-down source. Luann mentioned this kind of sales data, or maybe your import customs data if most of your fertilizer is imported in the country. So we use that as an upper level constraint on how much fertilizer is applied. And then we use bottom-up data on small scale surveys about what are those rates of application. Now, technically for the tier 1 method, you don't need the rates, but we're using a tier 3 method here in the US. So it's important in those cases to get to actually have those rates so that we can more accurately estimate the emissions. And I haven't seen a lot of tier 2 cases, methods for soil into emissions, but I would imagine if one is moving into a tier 2 method, the rates are going to be an important part of that, probably in a lot of cases. But maybe Luann, you have some additional information you'd like to provide.
Yeah, no, I mean, I agree. I think the best way is really to look at different ways or different sources of collecting the data. Obviously, if you don't have it every year, it is quite difficult to see that variation with time. But I think, as Stephen said, that if you look at the collecting it from fertilizer organizations, and then also if you have information, you see not everyone has information on crop areas and application rates. You could look at what is, as you say, an upper level of what those rates are. But I do think it's also quite challenging, depending on whether you have actual application rates or area estimates for the various different crop types. But I think the best, as you say, is just to try to look at various different data sources to gather as much information to help understand what that variation is over time.
Thank you both for your comments on this. Moving to a different topic, there is a comment in the question and answer section in relation to this perception of increasing emissions from non-Annex I countries, and the doubts that result in, given that in most cases animal livelihoods are decreasing in these countries, and that maybe this perception is based on that previously there was not adequate estimates in those cases. I don't know, Andreas, if you have a comment on that in relation to the trend of emissions from the livestock sector in the non-Annex I countries.
Yeah, no, it's a good question. I guess the most commonly used data set is FAO stat. And there's some uncertainty associated with the livestock numbers in that. There are some regions, I think in Southern African region as a whole, livestock populations have been decreasing, obviously, at the national level. I think, we forget there are lots of other really big populated other developing countries in other parts of the world. When you add them all together, populations are growing. So it's difficult to, I sympathize with Bernard's question from the Kenya perspective. Yeah.
Thank you. Thank you very much, everyone, for your questions and your comments. We are just on time. All the recordings will be made available after this webinar, and you will see the link and the corrective advice on this in the GRA website. So thank you very much for attending today. Thank you to our fantastic speakers that did quite a good job to presenting us with all these challenges and potential alternatives to resolve those. Thank you as well to the Inventory and I&NDC Network from the GRA for taking these webinars forward and for having us all together today here. Thank you, all of you, of course, for attending and participating actively during this session. So thank you very much, and we hope to see you soon in the next webinar.
Thanks very much, Marta. Goodbye, everyone.
Thank you all.
Thank you. Bye.
Thank you. Thank you.
Thank you.